Welcome to devMode.fm, a podcast dedicated to the tools, techniques, and technologies used in modern web development. I'm Andrew Welch from NY Studio 107.
I'm Patrick Harrington from Mildly Geeky in Boston.
And I'm Matt Stein from Working Concept in Seattle.
And today we'll be talking with Google dev expert Jay Phelps from Citadel Securities. How you doing, Jay?
Hey, I'm doing excellent. How is everyone?
Doing good. Welcome aboard. And we're going to be talking to you about a little something called WebAssembly. So if you were out in the Platte River in Nebraska noodling for catfish and some fellow noodler walked up to you and said, he's got a catfish clamped around his arm, and he said, "Hey, Jay, what is this WebAssembly thing?" Like, what would you tell him?
Man, if it was that extreme, I would probably just, it is something to that extreme. It would be like it's a machine.
Come on, the catfish is flopping around, man.
Yeah, it's flopping around. It's a machine language for the web. So its goal is to improve performance for certain things, but also make certain programming language a better target for the web, to be able to ship them in smaller bundle sizes, faster startup times, those sorts of things. It's really complementary to the existing web architecture. So it's not aimed to replace anything. It's aimed to complement and extend the web to open up more possibilities. There are cases where, it might be a better fit to replace certain things, but that's not really the goal. The goal isn't to kill JavaScript or anything like that.
I think you killed the catfish.
Oh, I am so sorry, Mr. Catfish.
No, but so if on the web, if we want to run any code, it's JavaScript, right?
Yeah, it's historically that has been the case. If you want to run any code and you want it to be standardized, because there's Flash and ActiveX and all this stuff. But if you want it to be,
we won't talk about that.
yeah, sorry, I said the F word.
Yeah.
But yeah, if historically that's been the case, JavaScript was your only way of running code, and so
what's wrong? What's wrong with just having JavaScript? Why do we need this WebAssembly thing anyway?
So the biggest thing is that JavaScript's a great language. And it's the biggest failing. There's failings, every language has imperfections, but the biggest failing is that it's designed for human beings to read and write by hand, right? It's a programming language.
Right.
So that means it's not designed to be a good compilation target, meaning you write in a different language that's not JavaScript and you compile that down to it. It's not designed for that. It's not a good compilation target. So if you wanted to use a different language, we can first start just by talking about choice, right? If you just choose to use a different language just because you prefer it, let's say you prefer C++ or you prefer Rust, or even a more dynamic language, let's say, or a more higher level language like Java or Go, or even Python, Ruby, et cetera, et cetera. Let's say you prefer one of those languages. Historically, your only option was to compile that down to JavaScript. And while it will work, JavaScript's Turing complete, so you can compile any programming language in the world to it. It won't run at the performance that you would come to expect for that language. And it has lots of other caveats as well that come with it. But it was a good stopgap measure. And so WebAssembly fills that gap. It allows more choice in the language you use. So you can choose a language that better suits the use case.
Yeah, okay, that makes sense. And I always thought it was a little bit unfair that JavaScript came along and then someone said, "Hey, you know what? I think we should run this on a server." And they came along and they came up with Node.js. That I'll be perfectly honest with you. When I first saw Node.js many years ago, I thought they were insane. I'm like, really? You're going to run JavaScript on my Linux box? I don't think so.
Sure.
In any event, but I thought it was a little bit unfair that they could just take JavaScript, this front-end language, and say, okay, we're going to run it on the server. But you can't take, for instance, PHP and then do the reciprocal thing and run that in a front-end browser, right? Because there's just no way to do it because it has to be running JavaScript. But it sounds like with WebAssembly, there are ways to write things in many languages and then compile it down to something that can be run in the browser?
Yeah, that's right. And just to clarify a little bit, it's not that you necessarily couldn't do those things. You can compile to JavaScript. It's just because it's not designed to be that, it's like it just was not. It won't perform, and you won't have the smaller file.
I've had enough of a headache reading the various JavaScript people have actually written. I can't even imagine what PHP compiled JavaScript would look like.
Sure, totally, yeah. And so that's the goal really of WebAssembly, is just to enable those things. Now we're really early in that goal in the grand scheme of how standards go, and especially a machine language, which is, a fairly low level thing and there's a lot of moving parts. But we're pretty early in that. So you won't be compiling your PHP to WebAssembly right now.
God, I hope not.
You can. There is a PHP experimental compiler out there that people have written.
No.
Yeah. Oh, yeah. Name a language, and probably someone has already started to experiment with compiling it to WebAssembly.
Oh my God.
But so right now, let me, I guess, take a step back. So right now, the V1 of WebAssembly, the goal of it was to try not to repeat the same mistakes that we made with ES 2015 or ES6. So the mistake we made was trying to cram everything into one big release. We knew we needed something, and it took forever. It took, over a decade to get really to fruition what ES6 ended up being. And so to try and not make that mistake, it was decided early on that the MVP would be fairly low level and fairly stripped down to just the fundamentals, a machine language that can run on the web that is designed for fairly low level use cases. So you'll be writing in things like C, C++, or Rust. These are systems languages that don't have things like garbage collection. That's one of the big things. But they also don't have a lot of like super dynamic behaviors.
When you say low level, what would define that? What do you mean by what would be low level code? Like I get conceptually that what you mean is you're not going to write something in WebAssembly that controls a checkbox checking on or off, right? But what is something low level?
You can, but for the most part, what low level really means is that it doesn't have dynamic features or things that require garbage collection. These are things like, so let me give you an example. The most obvious example is that for the most part, things to perform well under WebAssembly, things should be statically typed, or at least have the guarantee that if it's not statically typed, like, because C is quote unquote statically typed, but because you could do things like pointer arithmetic, you can basically access addresses directly and do math on them. You can totally
very to the metal.
Yeah, you can totally break the type system, right? And when that happens, then the app just stops working, right? The browser doesn't crash or anything like that, but there is no dynamic code that's like protecting you from this or something like that.
It gets worse though. I mean, you can in C, first of all, if you do something wrong, it may just not compile.
Sure.
Right?
Yeah.
Or if you actually compile, but you have something wrong, your application or your tool or whatever, it definitely can just segfault and then just crash and die. And I actually got started doing this early enough on that if you made a mistake, there was no memory protection, your computer just reboots.
Sure. Yeah. Oh, yeah.
Can you imagine? Like these days, if you make a mistake, you see this nice little error in your JavaScript console. But back in the day, man, you made the same mistake. You're turning the computer off and back on again.
Yeah.
Blue screen is back.
Exactly. Yeah. Now, thankfully, WebAssembly does protect us from those sorts of things. It's because it's a virtualized machine language. So it's a machine language, but it's for a virtual machine. It does isolate those sorts of things. So if you have the equivalent, if you dereference a null pointer, if anyone's familiar with that, if you dereference a null pointer, you call a function or you try and read a variable that actually is not in memory, it's not going to crash your browser. It's not going to crash the operating system. It will throw an error that if you don't have any kind of handler to handle this or what have you, the app just will stop working, and there it is. Like that's the end of your application. It'll just be dead, right? And the console will have an error message, but the error message won't be particularly helpful if you actually do dereference a null pointer. So it's a similar experience to the C++ type of thing, except the virtual machine does protect you from those things, and protect you as in protect the user from those things. And on a similar vein, it's too complicated to explain on a podcast. But there's actually the way the machine itself, the virtualized machine, was designed, it actually protects you from a certain class of exploits. Not all exploits, but for example, the most common exploit in the world, the stack overflow, right? You buffer overflow, inject some arbitrary code, and then jump to that address somehow, and you've now owned the system, right? Well, in WebAssembly, that actually does not work. It is actually not even possible, even if you're writing really poor C. Now, you can overflow a stack, and you can overflow buffers, right? You can do that because the specification allows you to do that. However, when you do that, if you injected some WebAssembly code into there or something like that, you will never be able to jump to it. Fundamentally, how the machine is designed isolates what things you can jump to and what things you can't. And the things that are stored in memory, basically the functions and procedures and stuff like that, are not stored in the same memory as your stack and your heap and all that stuff. So it's fundamentally impossible to do that. Now, to be very clear, there are definitely exploits you can still do, right? If you have indirect jumps, if you're familiar with those, like dynamic function call type of things, and you already had a function that also could be jumped to, you could possibly, figure out a way to exploit that and jump to another function and stuff like that. But you can't.
All right, hold on. But before we hack our WebAssembly stuff, let's take a step back.
Yeah, I get excited sometimes.
It's okay. Let's take a step back, and let's say that we've got this chunk of code. Let's say that we wrote it in. So I decided, what the heck? I've been thinking about it for a while anyway. I'm going to start learning Rust, right? So in preparation for this podcast, I've been trying to learn a little bit of Rust, and I've been going through the Rustlings, the little tutorial examples that they have and all that kind of stuff.
Adorable.
So let's say, that's what they call it. They call it Rustlings. And let's say I've got a little bit of Rust code. I wrote this Rust code, and let's say it does something very, processing oriented. Like maybe it compresses audio. Right. And I wrote it in Rust. I can run rustc on it, and it executes, and all that kind of good stuff happens. What are the stages that I can then take it from Rust into something that can be used by WebAssembly or can be used in the browser? Like how does that transition happen? What's going on there? Yeah,
so Rust in particular is a phenomenal example just because Rust, the core team itself, has decided to make WebAssembly a first-class citizen, to really, really double down on the WebAssembly experience. And because of that, it's actually pretty easy to do. If you do choose to use Rust, it's pretty easy to consume that in your app. Let's say that you're writing a utility library. You're not writing your whole app in Rust. And that utility library is then going to be used in JavaScript. You're going to call that. There's a project that the Rust team has called Wasm bindgen that basically gives you ability to expose methods and functions and what have you to the outside world, to JavaScript. And so when you use those, they're preprocessed directors or macros actually. But when you use those, you're exposing those as exports. And then when you compile it, all you need to do is load the WebAssembly binary using the fetch API, pass that into the WebAssembly compilation constructor, and then you get an object back. And this is in JavaScript, by the way. So in JavaScript, you do that. You'd get an object back that contains all of the exports of that library. And they're just JavaScript functions. Like you can invoke them just like how you would any other JavaScript functions. And Rust will do the job of marshaling, converting the values from a JavaScript thing to a WebAssembly thing.
But at a fundamental level, like when I write this Rust and I run rustc to compile it, the output is going to be something that is in that native processor's architecture that it can actually just like run it, right?
By default, yes. Yeah, you do have to there's a flag to basically, just like if you were compiling it to ARM or some other CPU or some other target, some other operating system, you pass in a flag, and that flag tells it, oh, WebAssembly, that's what I want to target. And there's actually...
Well, that's what I was getting at, is that instead of, like I was talking about, if I just build it natively, like I'm just building something for Rust, that compiles it for that. But then if I want to move it to WebAssembly, what ends up happening is it doesn't get compiled down to the processor's architecture. It gets compiled down to this virtual machine's bytecode. Right?
That's right. Yeah. Conceptually, I think it's helpful, and some people probably don't, but I think it's helpful to think of WebAssembly the same way you would think of any other machine language, like to think of it as if it were an x86 or ARM or some other CPU. And so, when if you're writing a code base that's going to be used cross-platform, going to be used in native and on web, you would implement it the exact same way as if you were targeting multiple CPUs.
And then the fun part is, like if I'm using Webpack as part of my build system, I can load this thing just like I would load a JavaScript module, and it will just like load.
Exactly. Right? Yeah. Webpack actually, they got a grant from the Mozilla Foundation to add support for WebAssembly specifically. And there's Rust loaders and C++ loaders, or you can just load WebAssembly modules just off the shelf or something like that. Because I think most people are probably not going to be writing their own code, right? And I think it's probably a good time to mention that if you're like, I don't write Rust, I don't write C++, why is this this interesting to me? Oh, believe me, it still is. We just kind of got down that track. So there's utilizing, I would say most people are probably just going to utilize WebAssembly rather than compiling to WebAssembly. So
as a perfect example, when we were prepping for this show, right, this is pretty amazing. Patrick and Matt, you're going to be amazed by this. So to record this show, we use something called Zencastr, right? And does the local recordings, all that kind of stuff.
Sometimes.
Stop.
Hey.
And then Jay was just like, hey, you know what? I want to check something. And he comes back a second later and he's just like, yep, Zencastr is using WebAssembly.
What?
All right. So it is. So Zencastr is loading just the same way that your average website would load a JavaScript that it runs and executes. Zencastr is loading a Wasm file that actually what it does is it looks like it does the MP3 encoding, and it loads that. So this Zencastr that we've been using for, almost 2 years is using WebAssembly, and we had no idea.
Sure.
Right. But Patrick and Matt, I want to ask you two that you've been hearing Jay and I go back and forth. Are you lost? Are you still with us on the Platte River in our noodling expedition? Or are there any questions you've got about it, about WebAssembly?
Yeah. I mean, go ahead, Patrick.
Yeah, I mean, the word assembly threw me for a long time. I haven't looked at WebAssembly, mostly because I assumed you had to code in assembly to actually get anything done. I thought it was just literally writing assembly, going back to Computer Science 111.
Right. And there's actually a funny joke about that. So inside the WebAssembly community, there's the joke that you'll hear that WebAssembly neither web nor assembly. And that's because it actually, and I would love to talk about this probably more near the end, but WebAssembly is actually not specifically just for the web, and it's not an assembly language; it's a bytecode. So
okay. So who is in the branding department?
Right.
Jay?
It just sounds too hip. It was going to be an assembly language at first, like a textual thing, and then it was going to be an AST, and then it was eventually a bytecode that's a stack machine. But so it just stuck, because it's hip and cool and sounds technical. And there is an assembly language for the bytecode, though. So if you do, it's called WAT, W-A-T. Mm-hmm. If you do want to write the WebAssembly by hand, you can. And
don't.
I tried.
As you might think.
Well, no, I didn't try to write that. Yeah, I tried to write a C++ Hello World earlier today, and it then lovingly pointed me towards line 116 of my assembly code, and I was like, I don't know. I guess it didn't like IOStream, maybe.
Yeah. Yeah. So if you're using mscripten, you'd have to enable the source map support.
Okay.
Special flag.
But you're right, Jay, though, that assembly language is something that a lot of people that have never done anything with it, they're like, oh, it's some magical thing. Honestly, I think most assembler, I say most because some are really difficult, but most are not that bad because they're really simple. The biggest thing is they're just incredibly boring.
Yeah, they're too simple. They're so simple that it's it's difficult to get anything done by hand because you have to do everything yourself.
It's like Matt. So Matt likes to do a lot of his own stuff. So before Matt can even take a shower, he's got to go out and he's got to make his own soap, right? Mm-hmm. And then he's got to grow the cotton to make his own towel, and he's got to do all this kind of stuff. And only then can he actually take a shower. Mm-hmm. And it's similar in WebAssembly in that, or sorry, not WebAssembly, assembly in general. You got to do everything by hand. It is brutal.
And WebAssembly is fairly the same. I mean, there is an implicit call stack because it's a stack machine, but it is very low level. There's no concepts of structs and objects and stuff like that. You're just loading and storing from a giant heap of memory. Now, to be very clear though, because this is where some people get tripped up, we're kind of going back and forth between talking about WebAssembly itself and using WebAssembly as a compilation target. So if you're using WebAssembly as a compilation target, you don't have to worry about any of that. Your programming language abstracts away it handles that stuff for you. It has the concept of objects. It has the concept of structs and fields and methods. We're just talking about the low level primitive of what WebAssembly is itself. It doesn't. Yeah.
So if I wanted to, I can just write something in Rust after I've gotten confidence by going through all my Rustlings, right? I can write something in Rust and it'll output it, and then I can load it via Webpack, and I don't have to know any of the magic that happens in between.
Exactly.
Right?
That is the goal.
Yeah.
Yep.
So, Jay, the last time I touched C++ was in a high school computer lab, and it was just after we did Pascal.
You were told to back away slowly from the computer.
That's right. They said you should look into design. And so that's what I'm wondering. Where my background's in design, that's why I'm allowed to do that. When is ActionScript 3 going to be a compile target?
Oh man. Oh, I have no idea. I have not. I know there has been some folks who are attempting to compile. By the way, I don't know if that was a joke or serious question, but
I don't know either.
Yeah, I put it that way to see how you'd answer.
Right. I have not heard if anyone is actually attempting to do AS3 to WebAssembly. It actually seems like eventually it'll be a good target, but too early yet. And we can touch on that in a bit. But I know there is effort to get there's an open source implementation of Flash, the Flash virtual machine, and there is a work to get that compiled to WebAssembly so that you could run Flash without any plugins. Which I think has a lot of merit, right? Think about enterprise type of systems like, let's say you've got a Flash app, which a lot of enterprise companies probably do. They've got a Flash app that's been running for, decades, or if not just a decade, and they want to upgrade, but they can't because they need to keep that old Flash version. WebAssembly could be a really great use case to enable those people to upgrade their browsers and get rid of old buggy Flash or something like that.
Well, next year is the year, right? Isn't 2020? Isn't that when Flash dies?
That's what I heard, but I haven't checked into it in a number of years.
I mean, I think it's already under hospice care.
Right.
I mean, it's not like it's thriving.
Okay, that's when Adobe is actually officially pulling the plug. Right. I should say.
And then
well, this seems like a good application, even if it's not Flash or ActionScript. It was mostly a joke, but there are galleries and like complex visual presentations that take a lot of horsepower to produce that still probably aren't managed or relate to web stuff. And I always wonder what people use to make those things. Right. And it sounds like this is kind of an exciting place for that kind of work to be web friendly.
Yeah. There's a lot of, like, if you wanted to get everything with Flash moving, like compiled to WebAssembly without the virtual machine, it can be a little difficult because, if you built the binary with like the builders, like, an actual like UI builder, crossing that boundary might be a little difficult. But as far as like getting the language itself to compile to WebAssembly, that's completely doable at this point. Performance, so let's say this kind of, I think, is a good segue to another point that a lot of people don't write Rust, a lot of people don't write C++, especially on the web. So why is this interesting besides consuming stuff? Well, we're going to get to a point where you're going to have more choice in higher level languages like your Dart and your Reason and Elm and AS3 and those sorts of things, those garbage collected. Maybe they have some dynamic sort of features. Those are going to be able to compile to WebAssembly and perform better than how they perform today compiling JavaScript. We're not quite there yet. And the biggest kicker is garbage collection, but we're going to get there. And I think it's really going to be like the big renaissance for the average developer, so that we have choice and we can iterate. And like, I think I can see a future where a TypeScript-like language gets a decent amount of traction. I wouldn't go as far to say as it replaces JavaScript or like dominates the market or something like that, but for very complex big apps, yeah, I can absolutely see something like that dominating in that small segment of the world.
So that makes me think of an interesting question. Does that mean we could see WebAssembly encroaching on territory that Babel, for instance, typically has occupied?
Absolutely. I think these there's different things, right? There's fundamentally JavaScript has a huge head start in so many ways. I mean, first off, it's a really great language that's really easy to learn. It's very forgiving. You can make stupid mistakes and it will forgive you, and you can mix types and all sorts of cool things. And so getting started, in the average developer, you can be very productive in JavaScript, more productive than you'll be in some statically typed language that everyone's talking about or something like that. But there does come a point where you're writing a significantly complex app and you want those niceties. You want that static type checking. You want it to complain and not fix things for you. And I think we're going to get to a point where a language does get popular for those sorts of use cases, and less people, I mean, we're seeing that already, not even with WebAssembly, that more and more people are moving away from Babel to TypeScript. And so this is sort of an evolution of that. Imagine, now you won't be, just to clear something up, this is a common question, will we be compiling TypeScript to WebAssembly? And the answer to that is TypeScript as it exists today, no. And the fundamental problem is that TypeScript is a superset of JavaScript. It's bolting types on top of JavaScript. So the same problems that come with JavaScript come with WebAssembly. And compiling the next question would be, well, why is compiling JavaScript to WebAssembly problematic? And it's not that you couldn't do so. In fact, JavaScript core, the JavaScript engine that is in Safari, is already been compiled to WebAssembly. So you can run Safari's JavaScript engine inside JavaScript is inside just Safari's JavaScript engine, if that makes sense. Like
Why?
mind meld.
Oh,
Why?
Why? First off, just to do it, but also there could be some benefits to security. You can run isolated code, not completely isolated, but nothing is ever completely isolated. But you could see some use cases for those sorts of things.
But isn't everything already run in a VM? Like okay. So
it is.
Anyway,
but you could let someone run isolated JavaScript, which today you cannot do. There is no reliable way to control a JavaScript environment. There's a proposal for like custom realms and stuff like that, but it has not yet shipped. So if you wanted to be able to allow people to run arbitrary JavaScript and you control everything, you control the realm, like what's available. Are there timers? Are there alerts? Are there any of those stuff? You can control it completely by running your own virtual machine inside the virtual machine. But anyway.
Yeah, I mean, the reason I was asking the question regarding Babel is, and by the way, how do people pronounce it? Is it Babel or Babel?
Oh my god!
Oh, here we go. It's
I've heard both ways.
I have heard both ways, but I would say
doesn't it?
I hear Babel more often.
Of course, yeah. Tower of Babel, yeah.
Whoever talked about the Tower of Babel?
I was listening to Wes Boss just a couple days ago, and
he was talking about Laravel.
He was talking about Babel.
Well, if Wes said it, I'm inclined to actually believe that this might be one of
well, Sebastian,
broken clock being right.
Right. I mean, Sebastian
twice a day, Andrew.
on this. He's like said it both ways before in the same sentence just to troll people. So yeah. I have.
Well, okay, it could be that. But I guess what I mean is like, okay, at a higher level, so at a fundamental level, we've got this JavaScript thing, right? And this is the one thing where we can run code on the web. And then lots of people are like, well, I don't really like JavaScript, or I want to run, ES7 stuff now and, whatever. So we have a process, so we compile it down to plain old ES5 JavaScript. Or people say, I don't like JavaScript at all. Like I want to use CoffeeScript, or I want to use, whatever, some other language, or Elm. And you said that there's PHP that compiles down to JavaScript. Couldn't we like swap out the layer and say, no, stop compiling to this dynamic language, this interpreted language, just swap that in for WebAssembly and compile it that way? Is that what you think might be happening in the future? Is that people that were doing that kind of, I don't know. Sean's going to get mad at me. Let's call it transpiling.
Right.
If they're doing that kind of transpiling, would they might shift to doing it to the WebAssembly target?
Absolutely. I think we're not quite there yet, mainly because of some features that are missing in WebAssembly to make it perform well. But absolutely, that is the goal. It's the absolute stated goal, is that if you're going to compile to the web and your language is not really close to JavaScript, then compiling to WebAssembly will eventually be the preferred solution. So all
right. There's an elephant in the room now, Jay, and he wants some peanuts. If this WebAssembly stuff is so awesome and so much faster, why don't we compile JavaScript down to WebAssembly instead of running it through an interpreter? Why don't we just compile it?
Well, it's really, really complicated to truly understand. So it's really easy to poke holes with my arguments
and I'm really dumb too. So talk slowly.
but. It's really complicated. It would take too long and be impossible to explain. But I can give high level details of like.
Imagine you're talking to a 12-year-old. Go ahead.
Well,
12-year-old eating a catfish.
Yeah, I would say go play outside.
Yeah. Okay. Fair enough. But
so the fundamental problem is just JavaScript is a very dynamic language. Now you may not be writing very dynamic code, but it's capable of doing very dynamic things.
I see.
And so you can do it. You can. It is totally possible, and it's already been done, compiling JavaScript to WebAssembly. But it won't perform as well as the built-in virtual machine. Why? Because the virtual machine, because JavaScript is very dynamic, it uses just-in-time compilation. So while your traditional JavaScript runtimes just used to plainly interpret it. But these days, what they do is they'll compile the code to like a naive version of machine code with a bunch of dynamic checks, some runtime checks to make sure that things are a certain type. But every time you invoke that function, it's going to check, was I right? It's going to guess about the types and be like, okay, this was a number. This is actually a 32-bit integer. It's going to guess that. And every time it checks, was I right? Was I right? Was I right? And after a while, it decides, I'm pretty confident that you're actually calling this always with the same signature. So I'm going to make a copy of this function with optimized code around that.
Right. So it's got an optimizer that runs and it analyzes the code as it actually runs.
Exactly. And it proves, it creates, it detects and proves what's statically typed, what's not. And it can fall back too. It can be like, oh, this wasn't actually statically known and this is wrong. And so that's, there's decades of incredibly the smartest programmers in the world building this stuff and trying to compile. Now imagine WebAssembly where it doesn't have any of that. It doesn't have any of that. Everything has to be statically typed, guaranteed. And so that means you either have to ship an interpreter or you have to ship all these runtime checks.
Yeah, so it sounds like part of what made JavaScript awesome, the fact its dynamicism and some of the evolution of the language was based on the fact that it was interpreted, and that very thing is what is making it difficult to compile it?
Yeah, I think that sounds like we're on the same page. Like, it's not that you can't write code that looks statically typed, but the compiler doesn't know that. It can't infer that because there's no... JavaScript is just too dynamic of a language.
And it's pretty lame for a compiler to say, it'll work for 95% of your code.
Yeah, exactly. So
that's not good.
But all is not lost because just because JavaScript has all these dynamic features doesn't mean that you couldn't write code that looks like JavaScript that isn't JavaScript technically. A superset of JavaScript that can be statically inferred and compiled to WebAssembly and perform really well.
That is JScript.
Yeah, right. Well, there's already experiments with this. In fact, like there's a project called Assembly Script, which is a combination of a bunch of projects. There was a Turbo Script, a Thin Script. All these projects sprung up, and then they all combined forces around Assembly Script. And the goal of it is basically long term to create a TypeScript-like language, but without all the dynamic stuff, so that it can be compiled to WebAssembly and perform incredibly well. It's really early, so while some people are already using it in production for certain things, you won't be writing like your whole application in it or something like that, unless you're writing maybe like a simple game or you just love pain, like you really love to do things hard, which people do, right? Like the people I follow on Twitter, like I see people writing, game emulators and all sorts of cool stuff in Assembly Script. And so it's all possible, but you won't be like writing your DOM application, your CRUD application in Assembly Script today. Eventually, absolutely, we're going to get there and you're going to have a choice of having that better developer experience. And I think TypeScript eventually will have, like right now they have options to like opt into more stricter modes, right? Or you can basically say you lose some of those dynamic features. I wouldn't surprise me. They have this, to be very clear, this is not on their public roadmap, but it's definitely something they're keeping their eye on. It would not surprise me if eventually TypeScript said, we're going to have a mode that does compile to WebAssembly, that you optimize, that you say, I don't want any of these dynamic features and I want to optimize, I want to opt into a very strict subset. And that doesn't mean that it's all or nothing. Your code could still interop with regular JavaScript libraries. You could still use Lodash and you could still use, all your libraries and stuff like that. It would just cross that barrier. It would call from WebAssembly into JavaScript and vice versa, back and forth. Your code would be WebAssembly. That other code would remain JavaScript.
Well, to your point about people doing crazy demos, there was a video and I'll link to this in the show notes, about Dan Callahan giving a demo where, and I may have part of this wrong, but he had basically an OpenGL canvas and you could walk around inside of it and there was a computer there and you could interact with that computer and it was run via WebAssembly. It was running DOSBox. On the computer, and you could interact in 3D with this like computer in the WebGL context. Yeah, you could interact with that computer and open up folders on Windows for Workgroups 3.1, like running that virtualized thing. And I'm looking at it, I'm like, what is going on, and why?
It's a crazy demo.
Also, why?
Yeah. It's so exciting because it's so early, but there's already been lots of really cool things that people have done. I'm just super bullish on WebAssembly, and that makes me a little biased, obviously. But I think right now for the average person, the biggest takeaway is if your app is not a simple CRUD app. Like if your app is just a simple CRUD app, all it does is it hits a REST API, a very simple REST API, it displays the data, has a form, you submit that form to the server, and that's it. WebAssembly at this point probably won't help that app. Now,
well, there is one way it might help it, right? Aren't they talking about potentially rewriting some of the guts of some of these frameworks in Wasm? Like, for instance, whatever does the shadow DOM in and the diffing algorithm in React and in Vue and that kind of thing.
Right, but I was trying to make the distinction that in that case, even if they did do that, it wouldn't matter to you because your app.
Okay, right. Okay,
like,
I'm sorry. You're right.
Yeah, sorry for the clarification. But if your app is so simple that like performance is never an issue, it's just simple CRUD. WebAssembly is not interesting to you right now. Now, in the future, what'll be interesting to you is the choice of languages. So if you do really like Dart, if you like Elm, if you like this new assembly script thing, if that's going to be interesting to you from a developer experience, not from a performance standpoint, but from a developer experience standpoint, the choice of doing that. But otherwise, if you do have performance issues, I mean, case in point, like eBay, for example, they recently did a blog post about how they're using WebAssembly. And you might think, well, how the heck would they use WebAssembly? And you're not totally off base. Like, it's a pretty simple CRUD app. Like, I mean, okay, I need to take a step back and undo that comment. It's not a app. It's a simple premise that, like, all I want to do is view a list of listings and I can buy it. Like, I mean, come on. Doesn't sound like it would be complicated. But there's a lot of complications that come to building a very robust.
Right. Jay, we'll expect you to be shipping your eBay clone next
week.
week.
Hacker news. I could have built that in a weekend. Yeah.
Right. Exactly. But
Matt, you had something you wanted to say, Matt?
Yeah, I'm just wondering, I mean, you're kind of touching on it a little bit, but who stands to benefit the most from WebAssembly right now? Like, is it a company that's built around an Electron app? Or, I mean, like, who is looking at WebAssembly very excited about the future of its evolution? Or is there any, like, kind of
I mean, there's
ideal?
There's people excited right now. The people excited right now, first off, you can't talk about WebAssembly without pointing out that like the game people are super excited because games are a really great use case for WebAssembly.
Yeah, right.
Unity. The biggest, both Unity and Unreal Engine both already support WebAssembly as a compilation target. The biggest issue with games and why it hasn't really like rocketed off is not technology so much as distribution model. There is not some de facto store where discoverability and people also are just so accustomed to, I play games on my console or I play games natively and that's what I do. I don't just like browse to someone's website and play a game or give them my money. I think that's going to shake out. Some of the companies have talked about, should we be doing a game store? And Google's toyed around with this in the past on some respects. But so there's the game folks. But for us normal web folks who don't do games, like, I don't do games. The people that get most excited are people that are going to they have some sort of computationally intensive thing. So like the eBay example, they have a QR code reader as part of their application, their web app.
Okay,
and
that makes sense.
It didn't perform well, the JavaScript version they have. And so they investigated using an off-the-shelf QR code reader library that was written in C++. And they saw it performed 50 times faster.
Oh my God. So this is a perfect case where they'll have this probably tried and true C++ library that's battle tested. And they'll be like, okay, I'll use this mscriptum thing and I'll compile this to the web and I'll load it via Webpack and bada bing, bada boom, they got 50 times faster.
Sure. Yeah. And in their case, the blog post is actually really interesting because they wrote some takeaways. They were very good. They were very, clear and open about the challenges that they hit and stuff like that, which is really good for future learnings. Like they weren't just like everything was rosy and that's it. Like they explained that. So one of the problems they ran into, and I don't want to spend too much time on this, but one of the problems they ran into is that the implementation of how the QR code reader works was different, right? It wasn't the same code base. So it's going to have different quirks. Some QR codes that the C++ one could read, the JavaScript one couldn't read, and vice versa.
But it's a standard.
Yeah, you'd think, but you're doing image recognition, right?
Okay, that's
so,
true.
How the algorithms you use to actually recognize those images vary, and so
they probably have a certain confidence level cutoff too, right? Like they have to have 70% confidence, and then they'll just go with it.
Right, exactly, and. They don't talk about that too much, but they do talk about, they start off with the WebAssembly version. If it fails to read it, they fall back to the JavaScript version, basically to give a better experience. But and I think that there's probably better takeaways. Like one takeaway might be that maybe the library they used actually just isn't that great. I don't know, because I've never had to read QR codes before. But and maybe like you said, maybe it's tweakable.
Well, I just think that I think the fact that I think the fact that you found that we're using Wasm without even knowing about it is really very compelling from the point of view of like we had no idea that this was going on, but it was.
Sure.
Right?
Yep.
And everything just worked. And I think that is a case where even if you're a web developer and you're like, look, I don't even write that much JavaScript myself. Sometimes I do, but usually I'm just taking packages and I'm putting stuff together. I'm never going to write my own Rust code that I'm going to build into a Wasm module and load. Like, that's just not going to happen. That's not me. That's not what I do. That's fine. But it sounds like you're still going to benefit from this because of examples like this, where a library will be taken that performs better or has some kind of specific functionality, and it will be bundled as a Wasm module. And you're not going to know any different because you're going to pull it in from NPM and it's going to load in your browser. Right?
That's exactly right. And that's one of the beauties and one of the main goals with WebAssembly on the web is to integrate that so that, like, in the browser, integrate it well, but also in the tooling as well. Things like Webpack, integrate it so that it becomes a transparent process, so that people don't, like, the holy grail of my goal and the goal of the community of WebAssembly is eventually we're going to not need to talk about WebAssembly and no one's going to even know what it is. Like, how many people, if you've ever written a iOS app, how did you know that they compile down to ARM processor? Do you know a single ARM instruction? Do you know how ARM works? Of course not. Who cares? Right. And that's the beauty of tooling. And that's the goal that we're going to get to. We're not quite there yet, but in some cases we are, in some cases we're not. Depends on how bleeding edge type of thing you're doing. But that's the goal eventually, is that WebAssembly will just be this silent, under the hood thing that, you know, the compiler people will know about, and you may know that you're targeting it, but other than that, you don't really know anything. It just works. You write your higher level code, and it just works. Or you consume your library and it just works. Case in point, if you use any kind of JavaScript tooling, like Babel, use Webpack, use Less or Sass, these type of projects already use WebAssembly, and you probably didn't even know that. They use a project called SourceMap. And so anything that uses SourceMap on the web almost always uses this NPM package. It's literally called SourceMap, source-map. And it was written in JavaScript originally by the Mozilla folks. And when WebAssembly came out, they ported it to idiomatic Rust. They didn't do anything crazy. They just wrote normal Rust code and compiled that to WebAssembly, and it was over 10x faster just by default. And they were able to push that even farther by doing some, like, you know, special optimizations and stuff that came out from doing the port. But that's a case in point of the consumers of the SourceMap library didn't have to do anything special.
Unless anyone think that this level of virtualization doesn't work, think about Apple did a major transition a number of years ago where all of their computers ran on PowerPC, right? And then they transitioned to Intel. Did any of our app code change when this changed over? No. Like, all you did is you had a new build target, you built it to that, and they had a virtual machine that essentially ran and did stuff very similar to the way that WebAssembly is working, I would imagine,
sure,
in terms of running this stuff. So this is a tried and true way of doing stuff, right? So, I mean, it sounds really interesting. Patrick, you had something you wanted to say?
Yeah, I mean, interesting. One thing you were saying is, you know, if you're just building, you know, quote unquote simple web pages, you know, right now this is probably not the right thing for you yet, but down the line it could be powering not just kind of back-end engineering, something, you know, that's doing audio processing like we're, you know, speaking into right now, but it could do a lot more. How would that work with accessibility? I've seen some cool WebAssembly stuff, but it's just kind of like plastering things on a canvas tag and you know, plopping into HTML. How would, you know, all the things that people rely on and the search engines rely on, if assembly is going to come out more from being like, you know, Java applets for 2019 and being this little self-contained little guy, how are they going to really implement into the fuller web and the open web?
Well, it really comes, so you have to really grok it, you have to go kind of low level. And we have to separate WebAssembly as an instruction target, like a bytecode itself, and the APIs you use to interact with the outside world. So the WebAssembly itself is actually fairly dumb. Like, it basically it provides you operations to be able to, like, compute numbers, right? You can do math. You can load
a simple stack.
Yeah. It's fairly simple. So it doesn't dictate the outside world of, like, how do I print to the console? How do I write to the screen? Those APIs are then deferred to the host. And in the case of the browser, that's the DOM. So in a lot of apps like you're talking about, they will, you know, if you're especially if you're porting an existing C++ app, if you're porting an existing C++ GUI app, not a library, but a GUI app, it's probably going to use Canvas because it'll treat it as a frame buffer, just the same as you were, you know, on a native operating system's frame buffer. It'll write normal bitmaps to that, and that's how it'll work. However, if you're writing with the web in mind, let's say that you're writing in Elm or Dart or something like that, and it's compiling to WebAssembly in some future vision, you'd use the DOM APIs, just how you use the DOM APIs in JavaScript. So you could create input tags and you can create divs and what have you. Those APIs could get exposed to your programming language, and you can use them the same way. So frameworks will sprout up, and there already are actually. There's even ones for C++ and Rust. There's like a React clone written in Rust, like so you can write JSX type of thing with the macros and stuff like that, and it's wild. Yeah. I mean, basically, if you think about it, people are going to do it. Just even if it's not a good idea, they're going to do it just to push the envelope and experiment.
So here's the thing, Patrick, and Jay, you correct me if I'm wrong here, but my understanding is that right now, Wasm doesn't know anything about the DOM, right? So Patrick, if you've seen an app that is running something in WebAssembly and it looks like it's, a Java applet or something, that has nothing to do with WebAssembly. That is whatever code is surrounding it that they decided to do that with. The WebAssembly chunk of it doesn't interact with the DOM at all. It's just being called by JavaScript to do various processing, and then it's up to the host app to do whatever it wants. Is that correct, Jay? Like currently, Wasm stuff, you doesn't even know anything about the DOM.
Yeah,
right?
it's kind of hard to wrap your head around, but so WebAssembly itself, basically right now, today, you cannot ship WebAssembly without JavaScript. You need JavaScript to, first off, bootstrap the WebAssembly, but also you need JavaScript right now to do anything interesting. So if you, let's say you just load a WebAssembly module, using JavaScript, you load it up and you don't give it any kind of like imports. You don't provide anything to the WebAssembly module. Well, at that point, the only thing it can do is basically load and store from memory and crunch numbers. And that's it. And it can't print to a console. It can't, write to a canvas or create divs or anything like that. It has no concept of that. It's not exposed. And that's part of the MVP. That was an intentional, because it's complicated to make those things interact between each other. It was decided, and I think it was the right choice, that JavaScript will act as the intermediary for now, as the V1. So JavaScript, you'll hear in the WebAssembly world glue code. And when someone says WebAssembly glue code, what they mean is the JavaScript code that acts as an intermediary. So in WebAssembly, you might call a function, like you might in your C++ code call a function that says like write to the canvas this pixel. What actually happens is you're calling across the WebAssembly boundary into the JavaScript boundary. JavaScript is then calling the canvas API on your behalf. It's delegating. And that's how it works today. However, there are a ton of proposals that have been in progress for the last couple of years on making WebAssembly a true first-class citizen of the web, where eventually you're going to be able to ship WebAssembly without a single line of JavaScript. It'll be able to access the host bindings directly. And so that means it could be able to print to the console. It'll be able to write canvas. It'll be able to create DOM nodes, all without a single line of JavaScript. The big kicker with it is garbage collection. That's the biggest kicker. We have to have some way of representing garbage collection inside WebAssembly, because right now, basically, you can only pass numbers essentially into WebAssembly, and so it under the hood has to create some sort of like a shadow stack where it holds a reference to the garbage collected JavaScript object until WebAssembly is done with it. So we need a way of passing that object. And I know that sounds very vague because it's a very low level detail.
Well, I want to take a step back though. For anyone who thinks that garbage collection is that thing that comes once a week to your house.
Thank you, Andrew.
You got it. So, I mean,
sanitation workers, programming.
Yes.
No. So I'm gonna do my best to kind of explain it. So when you need some memory to do something, you can allocate it yourself and you can deallocate it or whatever. But a lot of languages like JavaScript, you're completely insulated from this, right? You got a JavaScript object and you don't know anything about it, right? In terms of what memory it's taking up or anything like that. What garbage collection is something that on a regular basis, some kind of interval, will look through all of these things that have been allocated and it will throw out the stuff that's no longer being used, right? So that's at like a very basic level. So it's a form of memory management when we're talking about garbage collection. We're not talking about, the stuff that picks up your bins at your house.
Is it true that when you say garbage collection, it also is implied that that's something that happens automatically as part of that? Okay.
Well, typically, it depends on the implementation and all that kind of stuff. But yeah, it's going to be something that you never have to worry about, or you're not supposed to have to worry about it.
Right.
But Jay, to your point earlier about like crazy kids and the future of WebAssembly is not just the web. So the web is neither, or WebAssembly is neither web nor assembly. I found some stuff that said they're talking about like a Linux kernel WebAssembly runtime and WebAssembly as a first-class target for the Linux kernel. Like, what is going on?
Yeah.
What is this stuff?
Yes, exactly. And this is where I get even more excited. So,
okay.
Wow. So early on, the original people who started the WebAssembly effort, they realized what we're doing is unprecedented. There's never been a case where all the major corporations came together. Apple, Google, Microsoft, Mozilla, even Intel has helped out, and Samsung. There's never been a case where these people have all come together and said, let's make a machine instruction set. And name a bytecode. It's always been developed as a single from a single entity, or was then like initially developed that way, and then kind of organically back and forth. Like x86 originally designed by one, and then AMD added extensions that then the other people copied, and there's all sorts of things like that. It's never been just let's all get together and do this. And so they realized very early that this is valuable outside of the web browser. This is a very important thing. So they did a very good job. I wasn't involved at that early. I'm involved in the specification process now, kind of, but I wasn't involved at the early start. So don't give me credit for this. They're genius people. They knew that, and they decided we're going to make this very generic and then add extensions that are specific to the web. But so the very generic WebAssembly specification, it means that you can create virtual machines for this to run it on the desktop, or to even do like what you said. So there's a project to create a kernel module, a kernel extension to the Linux kernel to run WebAssembly in ring 0, which means run it directly in the kernel. Very, very, very low level. And
it scares the crap out of me.
Yeah,
it scares
like a terrible idea. It sounds like a terrible idea, and it may be a terrible idea, but the trick is this is unprecedented. Like traditionally running user land apps inside the kernel is a bad idea, and that's why microkernel architectures sprung up. Keep stuff out of the kernel as much as possible, because the kernel is more privileged. It's able to do things that the user land code is not. And however,
Jay, if I could, I want to see if this concept makes any sense. So something that's really big in the industry right now is Docker. In terms of you can use Docker to containerize your environment and your program and just spin stuff up. Does it make sense in any way to consider WebAssembly to be sort of a generic container for your binaries?
It does, and in fact, it sort of does. So first off,
your pause makes me think that I'm totally wrong.
We're getting into so I guess I'll start. So Solomon Hykes, one of the co-founders of Docker, he has a really, really saucy tweet. Saucy in the sense of like, I wouldn't have even tweeted this, but he's the co-founder of Docker and he can do what he wants. And he said, if WebAssembly and WASI, which is it's an interface that we probably won't have time to talk about, if they existed in 2008, we wouldn't have needed to create Docker. That is how important it is. WebAssembly on the server is the future of computing. The co-founder of Docker said that. And that blows my mind when he says that. Now, I want to he didn't clarify this, but I'm going to guess that if you did ask him about this, like you confronted him about it, I don't want to put words in his mouth, but I'm going to guess, and this is just my opinion, that he didn't mean that WebAssembly replaces Docker. What he means is the use case that he had in mind originally for Docker is solved by WebAssembly.
Okay, so my idea is not that crazy.
And there are, I think, Docker versus WebAssembly, there's a lot of cases where WebAssembly makes more sense. And there's a lot of cases where Docker makes more sense. And like very briefly, one of the biggest things is that if your only goal is basically, I want to ship a self-contained application, and that application, interacts with an SDK with the outside world, and that's it. It doesn't interact with other processes. It doesn't need the concept of an operating system. It doesn't care. And it doesn't care that what operating system it's running on. It interacts with an SDK, and that's it. WebAssembly is the best. It's like such a good target for that on the server. And there's things like Cloudflare and trying to remember who else did it. Trying to remember the name of it, but there's Cloudflare is like the biggest one where they're already doing that. They're experimenting with running WebAssembly on the server. And
well, that's a question I have for you. So one of the things that I've saw them talking about doing, them being Cloudflare, is the concept of edge workers, where they're spinning up essentially what are JVM, the V8 environments where they're just running JavaScript. Are they going to be spinning up, WebAssembly environments where they can just run arbitrary. I could write something in Rust and spin it off to an edge worker.
They already do support WebAssembly. It's not as first class.
Wow.
Like they definitely are. I don't know what they've talked about publicly, but there's definitely, it's very clear that they're going to continue to experiment with making WebAssembly a more first class thing. And the real reason why it's like Docker versus WebAssembly is that Docker comes with a bunch of stuff that you wouldn't need in that case. And so the startup time of spawning a container at the edge. So at the edge, meaning when you use Cloudflare workers, your application is basically put in memory every server farm that they have around the world. And when you request it for the first time, it gets pulled out of memory and then started up. And then if a request isn't made to that particular server in a little while, it gets spun down and put back in memory. And that is how they're able to afford to be able to have your stuff all across the world, is by those cost savings for them. Now, if your app's constantly bombarded, then it will always stay warm, right? Now, with containers, I don't remember the numbers off the top of my head, but it was over 100 milliseconds to start up the new container. And that actually is fairly fast, but in the web world, that's a lot of latency. And that's not great.
Yeah, right. That's a good bit
right.
overhead.
But with WebAssembly, because we don't need to spin up an entire operating system environment like a container provides, they're able to spin up isolates. They call them isolates. It comes from V8 very quickly. And again, I don't remember the numbers, so I don't want to throw them out. But they were significantly, like an order of magnitude faster. They were very quick. If I remember right, it was less than 10 milliseconds. I think they were like 6 milliseconds or something like that. But I could be way off on the numbers. But I'm not way off in the sense of the order of magnitude, though. It's a tremendous gain. And it's not magic. You're just doing less work, right? Like you don't need an entire operating system environment, why would you provide one? That's what a container provides. And so there is still use cases for containers when you need that, but when you don't, it doesn't make sense. And I think IoT, for example, has been really doubling down on containers lately. And I think that that's a mistake. I'm not an IoT expert, to be clear, but I have had some exposure, a decent amount of exposure actually. I've helped out an IoT startup, and I think it's actually a mistake to double down on containers. I think that they should be doubling down on WebAssembly because in those types of use cases, they don't need, the type of use cases that I've seen at least, they don't need an entire operating system environment. In fact, they end up bolting their own proprietary SDK that they're like, don't talk to the outside world, like just talk to our SDK. And that's like the perfect use case for WebAssembly.
Yeah, I mean, it sounds like if we're web developers, or even if, let's say we're not even developers at all, it sounds like WebAssembly is one of those quote unquote big ideas, TM, that is going to be affecting us and touching us in one way or another, regardless of at what level we decide to use or engage at it, right? Like, for instance, we were using it. We had no idea we're even using it, right? But as web developers, we might actually embrace it for certain things, or we might be bringing in packages that people maybe have created already and then dumping those in, and we don't have to worry about how it works underneath it. But if we did want to get kind of down and dirty with it, it sounds like there's tons of fun stuff that we could be doing. But I just wanted, as we kind of wind the podcast down, I wanted to see if, Matt, did you have something that you wanted to get in here?
Yeah, on the note of it being a big thing, I think, Jay, you're uniquely positioned to answer this question in the most interesting way. What has been the strangest or most surprising thing that you've seen that you wouldn't have anticipated just built with WebAssembly?
What is the strangest thing? Well, I mean, I honestly have expected a lot of strange things, so I haven't been too surprised, but I've been surprised at the rate of certain things. Like I was surprised how quickly they got Windows working, like Windows running. Windows, they're running Windows 95 in WebAssembly. So you can go to a website right now, and we can include it in the links, and you can run Windows. And not only Windows, you can run Firefox. So you can open up your Chrome browser, run Windows 95, and run Firefox and surf the web in Firefox.
Okay, so that makes a great demo, but what's the practical use?
There's no practical use.
Is it well, wait a minute. There might be, though. There might be. Like if we wanted to be able to archive these things, right? So, we wanted to digitally archive and shrink wrap. So we actually had a computer that could actually, it's not unthinkable that in, a certain number of years, we wouldn't have a computer that would run this stuff.
Sure.
So we're going to use a VM in some way, and Wasm might be a way to do it.
Oh, sure. I mean,
it's how you get Grandpa to finally update his computer and stop complaining about malware.
Just make a bookmark for Windows 95. Yep.
That's good.
That would be good. That is a phenomenal use case. But
Well, Jay, this has been fantastic, and I don't want to keep you too long, and I think we're already keeping you longer than we promised we would. But
No, it's totally. I love talking about this. I can talk forever, and there's just so much to talk about.
And the whole thing sounds amazing. And again, I'm going through the Rust training, and I'm going to get up to speed with it. I think realistically, I'm probably just going to be consuming packages, but I'm going to kind of be actively looking out for them now, because I think there might be some abilities that having a WebAssembly package might allow me to bring to my app, kind of like the QR code,
right?
That wouldn't be so easy to do otherwise.
Yep. Absolutely. And a lot of these, I think if you haven't already been exposed to WebAssembly, like knowingly at least, I think there will be a hype. I think it's an inevitable thing. You can quote me on this. I think it's safe that there will be a hype cycle in the next couple of years of UI frameworks doubling down on, we're moving to WebAssembly internally, and it's going to do this and that and the other and stuff like that. There's a couple features that WebAssembly need that will improve. It's doable right now, but to really be a performance benefit, there's a couple things that these frameworks need that we're going to be adding to WebAssembly. And once that happens, very quickly, I think you're going to see a lot of UI frameworks making a lot of buzz, and another round of buzz on this.
Well, if you'd be open to it, Jay, I would love to have you back on here at another interval, 6 months, a year, or whatever,
Sure.
And we can take a look at how WebAssembly has progressed, and we can talk about it some more.
Sweet. I would love to. I love talking WebAssembly.
Awesome. Well, that about wraps it up for another episode of the devMode.fm podcast. To have every episode delivered to your favorite podcast player, subscribe to our RSS or subscribe via iTunes or Google Play. And if you like what we're doing, leave us a review and look for Wasm to be implemented on the devMode.fm website in the near future. You can also follow us on Twitter at devModeFM. And we'd love to hear your thoughts on this episode. Leave us a comment on the devMode.fm website. For the devMode.fm podcast, I'm Andrew Welch.
I'm Patrick Harrington.
And I'm Matt Stein.
And thank you very much, Jay Phelps, for coming on.
Wasm!
You had to do it.
I had to do it.
That was awesome, Jay. And I did have. There definitely are like a few things that I still want to know about. I still want to ask you about, but I don't want to keep you too long.
Sorry about the little